Hello everyone, myself Dilesh Bagul. I'm a statistician. Today we are going to discuss some series of lectures of biostatistics. So today's topic is introduction to a biostatistics. In in this topic, we will see the definition of statistics and biostatistics, know the uses and application of biostatistics in in medicine and the related fields, know the common statistical terms, what is population and sample, enumeration of various types of data with suitable examples, collection and sources of collection of data. So before understanding the biostatistics, first we will see what is meant by statistics. So statistics is a branch of mathematics dealing with the collection, organization, presentation, analysis, and interpretation of numerical data. So statistics has three meanings: subject, data, and sample-based summary measures. So what is subject? Subject deals with the collection, organization, analysis and interpretation of data. What is data? Data, the term statistics is often interchangeably used as data. For example, health manpower statistics, birth rate of 5 babies, so that birth weight of 5 babies is also statistics. Sample based summary measures, that means any summary workout using sample data, for example, sample mean and sample standard deviation. So these are the parameters we calculated using the samples, and hence the sample mean and sample standard deviation are both the parameters of that particular set of data. So we call as parameter. So what is population and sample? So population is the group of people or study elements like persons, things or measurements for which we have an interest at a particular time. It means population is the group of units defined according to the aims and objectives of the survey. And sample is a part of population selected from the whole population, generally selected so as to be representative of the study population. Means what? Sample is the part of that population. We have apply our observations or study on that particular sample, and then we conclude that sample, and it is applicable for the whole population. So it is basically a sampling technique. Sampling technique is easier and more economical to study the sample than the whole population or universe. Sampling is most frequently used in surveys to obtain information about the population. For example, if we see this example, uh, study of anemia in adults and females. So here, adolescent females are our target population. If we see the diagram, first circle is considered to be targeted population, second is the study population, and we choose from sample from this study population. So here our targeted population is adolescent females and the study population is anemic females. So we choose some units from this study population, and that group of females we call a sample. So this is the basic criteria of sampling technique. In the field of statistics, the study and use of theory and methods for the analysis of data arising from random processes or phenomena. So here, random processes means the every subject has equal chance for selection, equal chance to include in the experiment. The study of how we make a sense of data. The field of statistics provides some of the most fundamental tools and techniques of the scientific method: forming hypotheses, designing experiment and observational study, gathering data, summarizing data, drawing inference from data. For example, testing of hypothesis. So here, hypothesis means hypothesis is the claim to be tested. First, from the beginning, we need to draw a hypothesis about the comparisons. Roughly speaking, the field of statistics can be divided into two parts. First is mathematical statistics and second is applied statistics. In the mathematical statistics, it is the study and development of statistical theory and methods in the abstract. And in applied statistics, we study the application of statistical methods to solve real problems involving randomly generated data and the development of new statistical methodology motivated by real problems. Now, what is biostatistics? So, biostatistics is the branch of applied statistics directed toward applications in the health science and biology. So, biostatistics mean we study the data uh, regarding the biological things or in the field of clinical sciences. The statistical methods and processes applied to the collection, organization, analysis, and interpretation of biological data. For example, the data related to the living or human biology, health and medicine, and statistical use in field of pharmaceuticals as well as in clinical research organizations. Nowadays, biostatistics is widely used in these areas like health statistics, medical statistics, and in vital statistics. In pharmacology, to find an action of drug, to compare action of two different drugs, to find relative potency or efficacy of a new drug with respect to a standard drug. So basically, these comparisons are made with some statistical analysis test and techniques. In public health or community health, it is called as health statistics. Deals with application of statistical methods to varied information of public health importance. In medicine, it is called as medical statistics. Deals with the study of the defect, injuries, disease, efficacy of drug, serum and line of treatment, etc. In population related study, it is called as vital statistics. Vital statistics is ongoing collection by government agencies of data relating to vital events such as births, deaths, marriages, divorces, and health and diseases related states, and events which are deemed reportable by local health authorities. Some of the vital statistics are as crude birth rate, infant mortality rate, and crude death rate. There is also use of biostatistics in the field of medicine to compare efficacy of a particular drug operations or line of treatment. Means what? Basically here comparison is made with the already marketed drug or reference study or the technique which has been already in use. Uh, they are compared with new inventory drugs or surgical methods. So these types of comparisons are made with the statistical techniques to find association between attributes, for example, oral cancer and smoking, to identify signs and symptoms of disease or syndrome. The knowledge of medical statistics enable one to develop a self-confidence, and this will enable us to become a good clinician. Good medical research worker, knowledgeable in statistical thinking. Everything in medicine, be it research, diagnosis, or treatment, depends on counting or measurements. So, statistics is widely used in epidemiology, clinical trials, or drug or vaccines, programming planning, community medicine, health management, and health information system. With height and if so, by how much has to be found. Now there were some common statistical terms we will see every time that are variable, constant, observation, or what is observation unit, or data. So variable is a characteristics that takes on different values in different person, places or things, or it is general term for a feature of the unit under study. For example, blood pressure, height, weight of the individuals, or blood pressure of patient, systolic or diastolic blood pressure of patient. Now, what is constant? These are the quantities that do not vary, such as pi and exponential value. So these are universal constants. Just like these values in statistics, mean, standard deviation, standard error, correlation coefficients, and proportions of particular population are considered uh, as a constant for that particular sample. Now, what is observation? It is an event and its a measurement. For example, blood pressure and its measurement record or measure of the variable are the observations. Now, what is observational unit? These are the sources that gives observations. For example, subjects or the patients. What is data? Data is collection of observations of variables recorded on one observational unit. There are two methods mainly we use for data analysis. First is descriptive statistics and second is inferential statistics. In descriptive type of statistics, in this method we organize, summarize and present the data using graphical techniques, numerical techniques and tables. And second one is inferential statistics. In this method we draw a conclusion about numerical analysis, for example estimation and hypothesis testing. Now, types of data. So there are mainly two types of data. First is qualitative data and second is quantitative data. So the tests are conducted for the qualitative data. We call that non-parametric test, and for the quantitative data, we call that test as a parametric test. Now, what is qualitative data and quantitative data? So qualitative data deals with descriptions. Data can be observed but not measured. For example, colors, smells, textures, etc. All the data comes from specific groups or classes such as attacked, escaped, died, cured, vaccinated, treated, not treated, like that. So these types of data are the qualitative type data sets. Now, second is quantitative data. Quantitative data deals with numbers, data which can be measured. So, measurable data is a quantitative type data. For example, length, height, area, volume, weight, speed, blood pressure of patient. So, these are the examples of quantitative type data. Now, types of measurements of scale of data according to the nominal, ordinal, interval, and ratio. Now, types of measurement of scales of data. First, nominal measurements. A nominal variable is another name for a categorical variable. Nominal variables have two or more categories without having any kind of natural order. They are variables with no numeric value, such as occupation or political party affiliation. Another way of thinking about nominal variable is that they are named only. Nominal is from Latin word nominalis, meaning pertaining to names. Nominal variables cannot be quantified. In other words, you can't perform arithmetic operations on them like addition, subtraction, or logical operations like equal to or greater than on them. It cannot be assigned in any order. It is basically represented on a pie chart. Here, pie chart displays data in categorical variable with categories with nominal variables. For example, gender, hair color, type of living accommodation like house, apartment, trailer, others, religious preferences like Buddhist, Muslim. So these are the some example of nominal variables. Here also, sometimes number are used to designate categories membership. For example of country or origin. One is represented to United States, two is represented as Mexico, three is represented Canada, and four is other country. So these types of codings are also made for nominal type variables. Second one is ordinal scale. The ordinal scale classifies according to the rank. means in order, included first, second, up to 99, like that. For example, high school class ranking, socio-economic status like poor, middle class, or rich, the Likert scale like strongly disagree, disagree, neutral, agree, or strongly agree. Level of agreement, yes, maybe, or no. Time of day, political orientation. So you don't have the exact word first, second, third. Instead, you can have different rating scales like hot, hotter, hottest, or agree, strongly agree, disagree. The ordinal scale, you might conduct a survey and ask people to rate their level of satisfaction with the choice of the following responses like extremely satisfied, satisfied, neither satisfied, not dissatisfied, dissatisfied, extremely dissatisfied. So these types of scales are ordinal scales. Now third is interval scale. Interval scale has values of equal intervals that mean something. For example, a thermometer might have intervals of 10 degrees, and here are the examples: Celsius temperature, Fahrenheit temperature, intelligent quotient or intelligent scale, time on clock with hands. Also, one thing that need to say about interval scale here, zero has something meaning. Means what? Zero temperature has some meaning. And last one is ratio scale. Ratio scale exactly the same as the interval scale, except that zero on the scale means does not exist. So on interval scale, zero has some meaning, but on ratio scale, zero has there is no meaning to zero. Zero is does not exist. For example, a weight of zero doesn't exist, and age of zero doesn't exist. On the other hand, temperature, with the exception of Kelvin, is not a ratio scale because zero temperature means something exists. That is, zero on the Celsius scale is just the freezing point. It doesn't mean that water ceases to exist. Weight is measured on the ratio scale. So here some are examples of ratio scale like age, weight, height, sales figure, ruler measurement, income earned in a week, years of education, number of children. It could be argued that as age isn't on the ratio scale, as age is zero culturally determined, Chinese people also have a nominal age which is tricky to calculate. Now scales characteristic, question and example, in which the different scales are compared, how they are compared, and what are their examples, how their comparison is made with different types of variables. For nominal variable, we compare like A is different than B, and the examples are marital status, eye color, gender, religious affiliation, or race. For ordinal scale, we compare like A is bigger than B or A is smaller than B, like that. And some examples are stage of disease, severity of pain, level of satisfaction. For interval scale, the comparison made like by how many units do A and B differ. And the examples are temperature or ACT score. For the ratio scale, the comparison made like how many times bigger than B is A, and examples are distance, length, or time until take. Now, different types of data for different types of measurement of scales. So we know that qualitative and quantitative are two main data types, and for qualitative data we use nominal and ordinal type variables. For quantitative data, there are two types of data, discrete data and continuous data. So interval scale is a type of discrete data, and interval and ratio scale both are the continuous type data. Now sources of data. The main sources of collection of medical statistics or data is experiment, survey or research. Now what are the different methods for collection of data? So there are two methods of collection of data, primary sources and secondary sources. The data is obtained by investigator himself. This is the first hand information, and the secondary sources are the data already recorded is utilized to serve the purpose of the objective of study. For example, records of OPD or dental clinics. Statistical survey or a sample survey. A statistical survey or a sample survey is an investigation about the characteristics of phenomena by means of collecting data from a sample of the population and estimating their characteristic through the systematic use of statistical methodologies. There are various surveys or methods that can be used, such as direct interviewing, telephone, mail or online services. So these are the basically methods of collecting the information about data. There is also one method which has been used by government agencies, is census. A census is a complete enumeration of population or groups at a point in a time with respect to well-defined characteristics, population and production. So data are collected for a specific reference of period. A census should be taken at regular intervals in order to have comparable information available. Therefore, most statistical censuses are conducted at every 5 or 10 years. Data are usually collected through questionnaires, mailed to respondents via the internet, or completed by an enumerator visiting respondents or contacting them by telephone. An advantage is that censuses provide better data than surveys for small geographic areas or subgroups of the population. The major disadvantages of censuses is usually the high cost associated with planning and conducting them and processing the resulting data. Thank you very much.